Alright, old Gatekeeper here. Mr. Little Boss out of the FLA out there around Orlando sent this up to me. He says, "What's up, Gatekeeper? This amp needs a pill and a little other things." Well, brother, this amp needs a lot of things. That's all I know about this amp. I don't know anything else about it other than him sending it down to me. I'm just going to go through and just point out the things that I have noticed so far. This amp's going to need a little bit of work to get it up and going. I see that somebody gave it a paint job recently. The only problem is they painted over everything. Everything. The switch, which that switch is broke. It's going to have to be replaced. It's probably broke during shipment or something. They painted over the SO239s. Those are going to have to be replaced. I am not going to take time to clean them. I know they're 19 years old anyway. They painted over the power wires, the remote, which that may be able to still be used. I'm just going to clean the inside of it with some acetone. There ain't nothing wrong with painting your box at all. It's just a good idea to cover up stuff that's going to have electrical connections. I didn't paint the bottom here. This is an old Viper box is what it is. I can tell what it is just by looking at it. I don't even have to see no logo or anything. But it's an old Viper box. Well, first off, let's talk about your fan. I see it painted over the fan too. The fan is the wrong direction. Let's see, that fan is blowing this direction instead of down. You want that air to come on top of your components through the opening right here and shoot across the heatsink out the back instead of sucking air through the vents up through this hole and out. See, then you're not throwing air on the components that way. You want to throw air on the components and through the heatsink. So I'm going to have to turn that fan around. Alright, let's go ahead and go through the list of things here. Alright, now here is an example when bigger is not always better. I opened up the box and these were just in here like you see it. Just jiggling around. I'm guessing these were soldered into place. These are only 100 microfarad but 300 volt. That's why these caps are so big, because they're 300 volt caps. But these are only 100 microfarad worth of capacitance. Meaning this cap is such low capacitance I could put this on the keying circuit. And the keying circuit would work just fine. It's so low capacitance I could take both of these caps and use them as a sideband delay, and it still is not enough capacitance for the amp to key on sideband. So this is an example when bigger is not better, but I can understand if you're new to it and just looked at the caps, you would think there would be some good caps to put on your hot bus because they are big, which I totally understand that. Alright, next thing. This pill is in here upside down. And I can tell by the solder work somebody has been in here with an iron that was not hot enough. You got to make sure you have enough heat on your irons. See, a lot of times people will go up to their local AutoZone or Walmart and buy one of them 20 or 30 watt irons. Those typically are going to be good for soldering little connections and stuff like that, but trying to heat up solder that's 19 years old The reason why I'm saying 19 years old, you can see this. I don't know if this is when it was built, but there's a date on here of 99. Mr. 827 X200 comp 5299. I don't know if that's when it was built or when the guy got it, or when a guy just got this particular amp. I don't know, but I know it's at least 19 years old. So this pill is upside down. It's not in there the right way. There's not even screws in it. Next, there are two 2290s in the two-pill section. Those are supposed to be 2879s for this model. My guess is, because you can tell they did not come with the box. Somebody has put them in there. My guess is it's, somebody blew the box up, and that's just the pills they had in hand, and they put them in there to see if it would work. And that's just a hypothesis of why I'm thinking they're in there. Next is probably a lot of y'all can already see. This is the first time I've ever seen anybody do this right here. This right here alone will render this amp unusable. Somebody has put a choke and has soldered the choke from the front of each side of the front of the transformer. Alright. The front of the transformer is supposed to be slitted in the middle because it is actually your first wrap of the transformer. That's why it's slit in the middle. It is your low winding, your low impedance winding. Soldering this choke like that is shorting out that winding to where it's not a winding anymore. Now it's different, of course, if you had power going to it. But this right here is no different from me taking a piece of wire and just soldering it directly over, shorting that slit there, making the transformer unusable, so it cannot even conduct from the primary winding over to the secondary winding. So all I can guess, somebody's maybe seen this somewhere and they tried to imitate it, but didn't know they needed to have the wire to extend from the hot bus over here. But it's already got a feed down here, so that's got to come off. I'm only hoping that this amp needs to be rebuilt. It really does, but I'm going to try to do this as cheap as I possibly can for you. I know you ain't wanting to spend a whole lot of money, so a lot of guys that I personally know would get in here and tear this box down and just rebuild it. I mean, it's a lot of nasty solder globs in here, this and that. It's going to be some work regardless. Next, this is not even connected to the one pill section, which I have no idea why not. I don't have a hypothesis of that other than it may just have came off. Next issue, your input loading capacitor for your driver section has broke off from ground, as you can see. See it wiggling down there? So it's broke off from ground, and this right here is not soldered to the variable. I'm about to test that variable to see if it's even good. Next issue is somebody put the wrong wattage resistor, but it looks like they may have put the wrong type resistor as well, meaning the wrong ohms. The actual value of the resistor, I can't tell because it's blown, but it appears to be, I think it's the wrong value. Next, obviously somebody blew a 10 ohm resistor right here and they tried to replace it with a 100 ohm resistor, 2 watt. See? It's been a while since I've seen an amp come through here that's, hey, no disrespect, but I don't know if you done any of this work, Mr. Little Boss. If you did, absolutely no disrespect to you at all, bud. Hey, when I first got into the hobby, I was mounting my damn antenna to my plastic luggage rack and wondering why it wasn't working. I didn't know nothing from a hill of beans. So I'm not never going to sit here and make fun of somebody. Literally just make fun of them. Because I remember when I didn't know nothing. Nothing. And I didn't even know how to solder. Even though I had soldered at an early age, but I didn't know then I didn't know how to solder either. I'm surprised anything ever held together. Next thing I noticed, the 330 cap right here on the input transformer has a cold solder joint. It's not connected either. I mean, this box it needs some work, man. It needs some work. I'm gonna have to disconnect this right here from the relay too. I want to test that metal clad down there. It's got a 150 metal down there, which I do like that. I like the way Viper did that. Next is just in all good faith, man. I'm gonna have to replace these power wires because this is. It might say 8 gauge on it, which I doubt it does. I mean, it's painted, so I can't tell. This is 10 gauge wire. And 10 gauge wire ain't going to cut it for a 3-fill. I mean, you got to have at least 8 gauge wire for a 10-fill. I mean, a 10-fill, a 3-fill. I ain't saying 10 gauge won't work. It ain't going to make a lot, but how cold is that 10 gauge going to stay, you know? I'm going to replace that, and I'm going to put you a standalone strain relief back there, too. Oh, boy. Let's see what they got for that load right there. 180, 180, it looks good. You can tell the Viper. I don't know if any of y'all can tell, but you can tell that Viper definitely was using Dave as a reference. But you can tell that if you look at any Viper built box, they definitely was using Dave, the original Dave made, as a reference. I mean, look at the way they feed the 1-pill. That's how Dave fed it. I mean, this is a complete Dave replica 3-pill is what it is. Back in them days when Viper was building. So this relay right here is not it ain't stationary. It has some double-sided sticky tape, but that's going to have to be remounted. See, it really would have been smarter for them to utilize the 2 holes in the middle, which I totally get why they did this, so somebody could turn it into a 4-pill, a 1x4 later. Which is totally understandable, but me personally, I don't even want to give someone the capability of turning it into a bigger box, because all they're going to do is put some mismatched pills in there, or I ain't saying it's not possible. They could put all brand new pills in there and all, but if they'd have put these 2 holes in the center, it would have dissipated the heat equally on the heat sink, for one, and also it would have put it to where they could line this relay, or they could have still lined the relay up, but this relay really should be more to the right in the center, as you can see. But you know, that's fine. It's just something I'm just talking pretty much, you know, what I would do personally. And I'm going to put a ground, as long as this is still usable. If not, I'm going to have to put you a new one on here, but I'm going to run a ground from here to the board. I am the, I ain't going to say the creator, but the compiler of the Y-mote. And I ground all of my connectors by default. So I went through the list of things. That's the things I'm, you know, that I see. Once I get in here digging around, I might see some other things. But basically, I'm going to take all these 2290s up, man, and hopefully we got at least one good 2290 out of these three that we can use in the driver section. Then I'm going to have to get you two 2879, used 2879. Then you ain't wanting to pay $75 a piece. I could tell that when I talk to you. But I'm going to have to get two matched 2879s for you to put in the final section here. And get this bad boy back working. But it is going to take a little bit of work to get there, but we'll get there one step at a time. Alright, we'll be back. Sorry, I know I ate up a little bit of time, but I ain't getting started on this tonight. I'm going to hit the sack and get started on this with a fresh day and a fresh cup of coffee in the morning. And hopefully I won't have a nightmare about this tonight. Because I do dream about building boxes and working on amps all the time. That's how you know you're a builder or a tech who loves what he does. Is when you dream about it and actually build amps and work on amps and you sleep. I do it all the time. I just wish some of that work I did in my sleep could manifest out into the open. Wouldn't that be cool? We'll be back. One more thing. I'm starting to remove all the bad components now. And one thing that I did not even notice last night when I was making the video, these feedback circuits, which are supposed to be soldered from collector to base, one leg is soldered to collector where it's supposed to be. And if you'll notice, the next leg is soldered to ground. And I will be honest with you, I don't know exactly what that would do to an amplifier because I've never done that, but supposedly, you know, it may not do anything with that high of capacitance, or just may just cause the amplifier to not work at all. I don't know. I've never put that much capacitance to collectors from ground. But anyway, these are supposed to be soldered this side of the capacitor to here, which is the base of the transistor. So it looks like maybe these were unsoldered at some point and they went to solder them back and forgot that it went here. But anyway, I just wanted to point that out for reference. It's the first time I've seen somebody do that before, but I know how it, well, this one right here is actually not even soldered. I didn't notice that either. But anyway, man, so we're getting this bad boy done. Just wanted to point that out just in case you did that, so you'll know in the future where these go. And they look to be in good shape, so I'm going to reuse them. I'm going to replace all the 10 ohms on 10 ohms just to be safe. All right, we'll be back. All right, Mr. Little Boss. We got her all finished up for you. Done, working, ready to go. Let's see here. Oh. Whenever I do a repair like this, I try to get in the habit of putting all the parts that came out of the box on the table, just so you can kind of see everything that came out of it. Kind of like a before and after type of deal. So, here's all the parts that came out of it. There's a couple more parts I did throw in the trash. There's a broken capacitor. There's a few things that did make it into the trash that didn't make it on the table. But so here she is, man. I tried to reuse everything that I could. I decided not to reuse the feedback circuits because they had seen their better days, plus the resistor on one of them was a little brown at the bottom, so I just went ahead and put you 2 new feedback circuits. Okay, we got you 2 matching Toshiba non-dot 2879, both matching, with a HFE value of 48, I believe it was 48. Pretty high HFE value for some used Toshibas. Okay, so we got you 2 really good used Toshibas that's in good health. Okay, that's a 2290. Please forgive me for it being smeared a little bit. That's what happens when people try to wash them with the wrong solutions. They'll smear them like that. So that 2290 is almost brand new condition. The HFE on that bad boy was 68. That's pretty much like brand new on an Atlas when you look at a 2290 being that high of HFE value. That 2290 is in very good condition. Very good condition. So, yep, I hate to say all 3 of these 2290s were blown, and all 3 of them were blown identically. They are okay from base to collector, but from base to emitter, blown on all of them. I always like to indicate blown pills with an X so I don't get them mixed up around here. I got a big bag of blown pills because I was like, you never know, maybe one of these days I'll get crazy lucky and find somebody out there in the world that knows how to possibly fix blown transistors. Wouldn't that be something else? And I believe it's possible. Like transistors like that are not completely blown from all junctions, that there may be a possibility of someone out there that can actually repair them. And wouldn't that be a cool day to be able to send all my blown transistors off to see which ones I can get repaired. Who knows though, who knows. So the variable was bad. Variable's all the way over there. It's supposed to be a 100 ohm variable, and it's damaged. It's reading, dropped it on the floor, but it's broke anyway. It was reading about 280 ohms all the way up and just all over the place, so it had been fried. So I had to put you a brand new variable on there. Big strong Russian variable. You're going to see me starting to use these now. I found me a good supply of them. These variables are strong, if not possibly even stronger than the ones that you see everybody using. I myself have not had one of these blown yet in any of the boxes I've used them in. I've probably used close to 60 or so of them, because I got a pack of 50. I got a pack of 50 and I think a pack of like 25, and I'm only down to like 10, but I found some more luckily and ordered some more of them. They're a little bit cheaper since they're Russian, and hey, some of the strongest stuff comes from other countries, y'all. So let me just go through everything real quick so I won't bore you here. Okay, got your 100 ohm 5 watt right here, which I always, that's just my style. I always like to put a 5 watt right there just in case you're running that variable down. This won't get all charred up on you. And that is one place that I do agree using a 5 watt 100 ohm at. Okay, got your 2290 put in here, a new feedback circuit, new 10 ohm down there, new 100 ohm load down here, new 100 ohm capacitor. That's this capacitor right here where the leg had broke off. Okay, I had to go ahead and put a new 180 right here on the output. That thing just looked bad. I think that's, no, actually that's the one where the leg broke off while I was putting on the 4.7. It just literally broke off, and that ain't the only thing. There was something else. Oh, I remember what it was. The metal 150 that was on there, which is actually reading as 80 picofarad right now. But this was a cold solder joint, and it looked like it was soldered, man. But as soon as I went down there actually, as soon as I went to lift the relay up to remount it, it just came up. So I was able to check it real quick too that way to notice that it had been devalued. So got your old $5 cap right here. These cost $5 from Mr. Charger. $5 cap. Look at it. $5. Four of them bad boys with a $20 bill. So I got you a new 180 right there. This 1000 was still good. That 330 was still good. Put your 2 new 10 ohms right here. Of course, got the 2 matching non-dot Toshibas. Real good shape, real good health. Put your new electrolytic on here just so you could have an electrolytic. Let's see here. I remounted the relay. As you can see, it is now stabilized. Put 2 new of the thickest 8 gauge that you can find out there from New Concepts. I love New Concepts. That's the wire that I preferably use. This is some really good thick 8 gauge. You can buy 4 gauge wire out there from some companies that is as thick as this is. It's one of the highest strand 8 gauges out there on the market. Trust me, I did my homework, and that's why I went with them. They're the cheapest that you can buy with the highest strand count. Okay, so I put you a new, I drilled that out and put you a strain relief there to hold that in for you. Put your lettering on the back, as you can see, since somebody painted it black. So I put you some white lettering on there, out and in. Okay, put your 2 new SO239s. Of course, that's these right here that you had painted. I actually tried to clean them up just to see if I could clean them up, and it's just going to be too much trouble. So I put your 2 new SOs on there for you. Put your new knob on that variable. See, that's the only negative thing about these variables is the shafts are a little bit smaller, so I have to pay a little bit more for the knobs. That is a $3 knob right there, brother. It's hard to find knobs that take that kind of small of shaft for a good price. These particular ones cost $3 a piece. I think I got like 8 of them. Put your new switch. See, this box needed a lot of things, man. Put your new switch, new current limiting resistor for the LED, and as you can see, I put you a holder, LED holder, my style. Funny thing, man, is Mr. Beavis, Mr. 018 Beavis. I done a 2-pill build for him a couple of years ago, and he had sent me some lugs, some ring lugs or whatever, that actually fit on my 3mm LED holders perfectly. And what that does is that allows me to not have to run a ground wire from here to the board. So it saves me a little bit of time, right? To me it does, because I've got pretty quick at putting these on here. So this grounds against the case at a good stable way with a nut on there very tight. You see some people just putting it on the back of the switch and tighten it down, and that switch gets a little loose or something, and you know, gets oxidized back there and you lose your LEDs ground. Well, this right here is tightened very, very tight with a nut. It's not coming loose anytime this decade, hopefully. But that's my style, the way I do my LEDs, instead of having to run another wire down here to the board. And so far that I know of, I'm the only guy that uses 3mm LEDs out there, and you wouldn't even know it if I probably didn't tell you. And I just started using that because I found these lugs. Now I have found these lugs in different sizes now, because I finally ran out. I hollered at old Beavis and asked him if he knew where he got them lugs from, and he's like, nah, I don't know. So I found some in China that I ordered, and I found some different sizes, so now I can use them with the 5mm LEDs if I want to. But I've just gotten so used to using 3mm LEDs. Alright, man, so I think that's about it, bud. Of course, I switched your fan back around, and put a lug on there for your for the ground of the fan. And I think that's about it, brother. It was a good bit that needed to be changed. And I cleaned up had to clean up the board in every spot that I was going to be soldering. I had to retap the pills, the holes for the pills. I had to retap them because they were a different screw being used with them, which they'd like to use back then, like a sheet metal type screw. So I retapped them, and the way that I like to do these older boxes when I have to retap them is I like to use very long pill screw holes so they'll have more grip when they go down. So had to retap all them, blah blah blah. So there you go, man. Got you. I've got this plugged in the remote just to show you that the remote works. And I already got the power wires soldered for you if you want to add some Andersons on there. Alright, we are hooked up to the 100 amp unregulated supply on the medium tap. Okay, we're going to hit it with a 4-watt radio, just 4 watts of RMS drive. Alright, this is the feed through the box. Hello, hello, hello. Hola. 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 Good match. Alright, go ahead and flip the box. Well, actually, go ahead and flip the box on with the remote just so I can show you that it works. I need to do this more often just to show people the remote works. Usually I like to keep a Wiimote, a wireless remote, on, off, works just fine. So I can be using a Wiimote, but every time I make one for myself I end up selling it. That's the kind of stuff usually works. So anyway, variables all the way up, 1000-watt slug. Looking at the bottom scale, oh, a little bit over 200 bird. That's 100 bird watts per pill, just with a 4-watt drive radio, and that's still with a 47 ohm potentiometer. I'd like to add. Oh, that's a little bit over 200 bird. Let's turn this thing halfway back and see what it does. Oh, about 180. Turn about 25. Oh, about 150. All the way down. Oh, a little bit over 100. So that's what the variable's doing for you. Okay. And good low dead key, as you see there. Oh, here's your input reflect. Oh, absolutely beautiful. Oh, hardly no movement whatsoever. Alright, here's PEP. Oh, 600 watts. What this thing doing? It's doing about 600 watts, no doubt about it. Oh, Gatekeeper letting the mop flop. 600 PEP, a little bit under. Getting down, getting down. And that is at 15.4 volts. Oh, 15.3 volts, sorry. Alright, so this thing is working well. If I can make a 3-pill do 200 bird with a 100-watt, with a, excuse me, a 4-watt radio, 4 watts. If you don't believe me, let's turn the amp off. I need to do this more often just so people can see. Okay, I'm going to flip this around. It's my 10-watt slug. Ooh. You know what? I just unplugged my my radio. That's what I love about a Cobra 29. You can key your Cobra 29 without it plugged up by accident, and you ain't got to worry about blowing it most of the time. I don't know how many times I've keyed this radio without a coax plugged in, and it's still kicking. Still kicking. You can't do that with a MOSFET radio. You got a better chance of it failing on you. A little bit under a watt dead key. Oh, 4 watts. It's a 10-watt slug. Looking at the bottom scale. Oh, letting the mop flop. Hey, we letting the mop flop with this thing talking about 3 watts when you're sitting there just talking on the
the old hammer like this, man. Doing about 403 watts there. Modulating up around 3.5, no doubt about it. Letting the cop picking mock flop out here around northeast end of Georgia on this old dummy load. No.
4 watts, right on the dead nuts on. Alright. I'm going to go ahead and hook up the hot radio. Just let you see this thing working a little bit more drive. Alright, what we're going to be doing now is we're going to be double. Alright, I just got cut off for some reason. When I key my microphone down on this radio, on my bench radio, it dead keys a little bit less than a watt. I need to turn my dead key up a little bit to a watt. But anyway, it dead keys 1 watt. Okay? And when I modulate into it real strong, it swings up to 4 watts RMS on my bird meter. Okay? Now, like I said, I can go down there and turn my dead key up to 4 watts and key my microphone and show this amp doing exactly what I just showed it swinging. But we just like to show that swing. See, that's what the CW reading watt meter. Now, what a lot of people can do, and this is what you can do when you go to when I show the peak mode, I can turn my, with my radio, I can do this. With my radio, I can turn it up to a 4 watt dead key. Okay, and audio, and it won't be swinging backwards, but I'm right there at that threshold. If I turn the dead key up any higher than that, I'm going to start swinging backwards, and I'm saturating the transistors. At that point, though, let's say I'm dead keying 220 watts, okay? I then can turn my peak meter on at audio, and you'll see it then swing up to what it was doing, about 600 watts. So that's what we're showing when we're showing the bird meter. You know, you can almost say that we've kind of become masters at tuning FM amplifiers, and we don't even know it. A lot of us don't even know it, because that's how you would tune an FM amplifier to get the most out of it under a carrier, because you have no swing with FM, if that makes any sense. So I don't know if anybody's ever explained it like that to people, but maybe that'll kind of help you out. So we just like to show you the swing. But now, I'm just giving you an explanation of what we're showing on these bird meters. Okay? So that's basically all it is to it. So now, this radio that I'm about to turn on, it can swing all the way up to 8 watts RMS without swinging backwards. So I can make it dead key up to 8 watts without it swinging backwards. Alright. You know what? I got to plug in my mic. Give me 1 second. Alrighty. So we got the hot radio hooked up, which is going to be now doubling my drive from 4 watts to 8 watts. Okay. So we're on the 1000 watt slug. Oh, dang. Dang. Doing nice. Let me see if that was 360 or 380. Oh, it's about 360. Oh, alright. Oh, about 700 watts. And that is at 15.6 volts. Because what I just did is turn the unregulated supply up to the 100, up to the high tap, which gives me full 100 amp worth of current capable. And because I keyed it up on the medium tap after I plugged the microphone up, and it was sucking it down to about 13.8 volts. So this thing's good to go, man. Doing over 300 bird on 15.6 volts with 8 watts of drive, about 700 peak. And on regular close to stock voltage, she's doing 200 bird, let's say 550, 600 watts. So she is good to go, man. Sorry I got off in a little talking rant there, but that's what I do. Appreciate you being patient with me, brother. I'm gonna go ahead and get the top on this thing, get the screws in it, get it packaged up and get it out to you, bud, out there in the Florida area. Mr. Little Boss out there around the Orlando area. Mr. Gatekeeper saying, appreciate your patience again, bud. And 73s. I hope this bad boy lasts you. I'm glad to get it back in operation for you. And a lot of people would have probably just threw this box away, man. It needed a good bit of work. And I've pretty much spent my day on this thing, man. So, it is what it is. Got you some good long cable on there, like I said. I already soldered up. Got some heat shrink on there for you too, so you can put some Andersons on it if you want to. And there she is. Alright, bud. We're good and gone. Got anything like this you need done, give me a shout and I'll help you out. 73rds. Old Gatekeeper said it. Bye-bye.